Good evening, good afternoon, good morning, everybody. Welcome on into the Dragon's Den. My name is Digital Dragon, and I'm a 3D printing variety streamer here on Twitch. What does that mean, you might ask? Well, it means we do everything from printer assemblies and mods, like our Flying Bear Reborn 2 here, to full-up printer builds, like our Voron Trident 2.4, the other 2.4, to some prototyping stuff, like our 0G Mercury 1.1 here, which was a closed beta for the full frame build, full enclosure, to our Trad Rack beta that we took part in, to a beta that's going on right now in the Trident, which is why I won't be showing the Trident anytime soon on stream. So yeah, that's kind of what I do. I also do a bunch of 3D printing of various things. I do some cosplays similar to like the helmets that are up behind me. I've got a full armor set cosplay that I've been working on in the background. And pretty soon I'm going to be working with Creatix Brit to do, I'll say, his and hers light and dark Star Wars droids. Welcome on in, Nick. Hey, Hybrid Robotics, how's it going? Well, so the beta going on in the Trident, this is a standard Trident build, so that there is a component on the tool head that I am in a closed beta on right now, that I'm under NDA on. So that's why I won't be showing anything in the Trident, and that's another reason why I'm using the Trident, because it's got the smoked panels, so you can't see inside the build. If you're familiar with Nero 3D, you'll remember that a lot of times when he was doing some various things, he was using Tallboy, which has the black panels on it, so you can't really see inside of it. Very similar to what I'm doing. Okay. So we're switching back over. On Saturday stream, we worked on Chewie's 2.4 build, and we're sort of in the same place between the 2.4 and the K3 build, and the fact that it's down to wiring. The last streams, we got all of the software config working so that we've got the basic, not configuration, but the firmware installed. We got mainsail installed. So we've got all of that going on both of those builds. So now it's just down to let's finish wiring. Let's make things a little bit pretty. On this particular build, I'm not going to get it fully, I'll say, closed up yet, simply because I need to verify and get the motion system going before I put any panels on. So on the K3 build, let me go ahead and switch screens here. Let's see, Hybrid Robotics, not too bad. You discontinued a robot project and you're moving forward with your own. Nice, very nice, Hybrid Robotics. So I've got a few little robot projects, like we've got the Ivan Miranda mini tank that I've been working on that I need to get with Evil Diesel on, because he says he has the I'll say basically the down converter, buck converter, UBEC, whatever, to work with that so that we can run the receiver, the radio receiver, off of the standard battery pack, which may be supplying too much voltage. So I need to get that going so I have my little tank to run around. I've got a other project here. This was just the simple, buy the kit off of, I think I got it off of AliExpress. It's got the 4 little independent motors on each side. It's got independent suspension. I've got the battery pack for it, the batteries, the motor controller and everything for it. I just need to continue with the project, and it's one of those things that's been put to the side while we've had my son in town. But one of the things that I want to do here before we get started too much is just do a little show and tell. So right now, and I'll show you more when I flip this around. I can't move it around too much right now because of the length of my power cords. But I'm going to flip the switch on the back left side here for the main power supplies, and then flip the switch for the Raspberry Pi because I'm still running it off of a dongle right now. Yeah, it's just cool little fun projects to have around and tinker with. And everything working out right. And I will say I've got my 2 dummy thermistors in here. And my screen's still wigging out a little bit. Believe it or not, I know why it's doing that. So there's electrical interference. And there we go. We're coming up, we've got clipper screen. So what you were seeing there was a little bit of electrical interference. And I'll be able to show you this once I can power it down and turn it around. But we've got these metal side pieces that provide some added rigidity to our printed parts. And this will then mount up on the top, right? So the screen slots in here, and I've had to cut out some of the metal edges on the side. On one side, I did put Captain tape because the Raspberry Pi actually sits like right on top of it on the one side. On the other side, I cut out because there's a 4-pin socket and then a 2-pin header right next to it. I think what we're seeing there is that 2-pin header is either too close and it's getting some electrical interference because it's picking up off of the metal or something. So I just need to put some electrical tape or some Captain tape and wrap that edge of the metal piece there, and that should go away, no problem. So yeah, that's kind of what we're seeing there. The other thing that I wanted to show you is like right now, this is the back of the printer. Front of the printer, back of the printer as the way it goes, and the electronics go on the back. Well, because I've got the display there on the backpack, this is now going to be the front of the printer. So I have some options here. I could have either one, moved the whole backpack over on this side, which wouldn't have been too bad, except the bed power cables come out this side of the printer and the hole for them is down here. Well, if I physically move the backpack to this side, the hole would have been down here, which means my bed wires then go underneath and over, which means it could catch on the Z motors and various other things. So I wanted to keep the backpack where it was at, which means I'm going to switch this panel and the door panel. So the side panels on these are just like the back panel. They're opaque and they're the black aluminum. So this will be opaque, this side will be opaque, this side will be the clear door panel that has the etching on it. Now, I believe Old Guy Melts Plastic, OGMP, kind of did this setup, and that's where I got this from. He physically changed the way, so today, this is X, this is Y. So since he's moving his door here, he changed it so this is X and this is Y. Now the problem with that is whether or not we've got to change the end stops and do a bunch of other changes in the code. I think for now, I'm not going to mess with that. I'm going to leave this is X and this is Y. It's going to be weird looking at it from this way, but that may be easier for me, and later on down the road, if I think I really can swap it easy without a bunch of weird changes, I'll do that. And the other reason is because we have a purge bucket back here. So I'm able to use all the standard purge bucket macros because I haven't changed X and Y. If I change X and Y, I've got to go through and make sure that all the purge bucket macros and everything get properly changed. And it's just going to be a lot more tinkering with the code to make everything work right. Okay. So that being said, right now I'm going to go ahead and power this back down so that we can then unplug it and actually start working on some wiring. And when you're shutting down a clipper machine and you do your shutdown, do it in the software, tell it to shut down, and then wait a few minutes. Or not a few minutes, but wait a good minute before you physically turn the power off at the switch. And the reason I say that is it's writing your Clipper environment out on your Raspberry Pi to your SD card. And if you remove power too quick, then it's actually going to be in the process of writing to that SD card, and you can corrupt your SD card just as if you had hard powered it off without shutting it down appropriately. So something to be aware of. You may also see there's a post-it note here, and that's a note to myself that says, oh, it's kind of hard to see with the E3D sign on there, but it says change fan voltages on Karabiner. So I just realized I was looking through the Kerabiner documentation, and by default, the Kerabiner toolhead board comes set with the part cooling and hot end fans set to alternate voltage. So there's two voltages that are sent to the toolhead board. Whatever the hot end is getting, in our case 24 volts, and 5 volts. So all of these fans electrically are set to 5 volts, but they're all 24 volt fans. So what that means is I will need to take the mini Sherpa off to be able to get to the top of the tool board. And I'll take a look at there whether or not I need to go ahead and take the tool board completely off to do the soldering. But really what I'm doing is removing a blob of solder on one set of jumpers and soldering the other set of jumpers. So that's not too bad. But once again, we'll take a look back here at our electronics. So we have our long 6-foot cable for our beacon probe that's plugged into our Raspberry Pi. We've got our Annex Engineering Constellation Supernova board. So this board can take up to 56 volts for running your 5160s. So in this case, we're running 4 Big Tree Tech 5160T Pro step sticks. And that's 48 volt direct connect to the board from our 48 volt UHP 248. And then we've got another UHP 224 volt that feeds up into our 24 volt Wago pop out here to feed a Big Tree Tech SKR 3EZ board. These are just my thermistors. I always keep a set of just cheap generic thermistors because you'll want to run these into your board so that you can verify that you're getting your configs right. Okay. If you get to a point where you're getting through your printer config and it finally comes up and throws an ADC error, that's a good thing because that means that your board configuration is good enough that it's going fully into Clipper and evaluating the temperatures, and it's just not getting temperatures. So that's how you get around that, is just throw a couple of thermistors in. You'll see me do this more often when I've got everything connected up but a heated bed, and I'm just plugging in the heated bed. Hey, welcome on in, Major Gamer Geek. Stephen Poole, welcome in. Why Not Because, welcome on in. Two Wolf Designs. Make it work, then make... Exactly. You make it work and then you make the changes. Hey, Danny Barr, welcome on in. Hello and Happy New Year to you too. So, one, I need to tighten this down because that's going to drive me batty. So on the way we've laid things out here, you'll see that I've moved things around a little bit. And what I've done is, sorry for putting my head there in the way. This board stayed the same. This board used to be up here at the top because I was going to have my, all my other power junctions down here. Looking at it and how everything flows, I decided to move this down and move my 24 volt over. So what we're going to do is we're going to use, this is a Thompson, but this is a 12 or 24 volt to 5 volt butt converter, 10 amp. So we're going to take this and we're going to just use VHB tape and VHB tape it probably right there. And we'll be able to pull 24 volt into it and then bring 5 volt out and plug it into the screen with a USB-C. I just bought some USB-C to pigtails. So I'll just cut that down and plug that in right there. So this will be providing 5 volts to our Raspberry Pi and the screen. Okay. The other thing that we'll have is our bed, and our Z motors are going to come right up in this corner. I'll be able to bring the 3 Z motors up and plug them into Z, Z1, Z2. We'll bring our bed wires up, and I'm going to mount an SSR right here. And I'm going to mount it in such a way as the load side, right? We've got the load and the input. The load side is going to be facing down. And it's going to be in here just like that. So our bed's going to come straight up into the SSR. Our 110 power is going to connect into the SSR. And then the top pieces here will go into our bed out or into our HE1 out. One or the other will run into here. Now, this is made to be heat sink directly down either through a metal mount into a DIN rail or have a heat sink available there. What I'm seriously considering doing is marking out, drilling 2 holes into the bottom of this, tapping those 2 holes, and mounting this directly into this back panel. So this back panel is 3mm aluminum plate. So I should have enough there, and even if I don't, I can run through and put some M4 nuts on the back. And as long as I can get my hands on some black M4 nuts, and if not, then I'll just spray paint a couple of M4 nuts black so that they won't be as visible. But we'll mount this directly to this back panel, thus making this back panel a heat sink for our SSR. Okay. Normally you would have this mounted right to your extrusion, but as you can see there, there's no room for it between that fan and the brackets here. So I did not feel comfortable, and I can't move these extrusions because once again, they're mounted directly to this back panel through set holes. And I don't want to run the SSR like all the way up here just to give it, you know, a place to mount, because that would be bad. I don't want to run any of my 110 up, and I don't want to run this up. So I'm thinking about mounting this directly to the backing plate with a couple of M4 screws that go directly into the back. So that's my thought for those 2 things. The SSR I'll probably do off stream, because what I'll do is try and put some type of collection piece at the bottom, even if it's just loops of blue tape. I'll put some blue tape here, mark my holes, punch them, and then drill them to the correct size so that I can then tap them. And then that way I'll have some blue painter's tape that's just done in a, you know, like a U shape, so that it can collect all the chips, so we won't get chips of metal all over pertinent parts here. So thank you for the follow, Amateur Tub 7. So one of the things that I was looking at right before the stream here was in the configuration file. Hey, Solar 3DP, welcome on in. Happy New Year. Happy New Year. So in the configuration file here, it kind of shows the layout of the motors. So on the left side, when you're looking at the printer from the front, you have your X in the front and Y in the back. And on the right-hand side, you have your Y in the front and your X in the back. And it's known as Y1 and X1. So your X motors are front left, rear right. Your Y motors are rear left, front right. So they're diagonal of each other. Your Z motors are front left, Z, center back, Z1, front right, Z2, just like it would be on a Trident, right? And that's critical for your Z tilt adjust, okay? And that's why I want to try and keep everything the same, because if I go to change anything, I could potentially have some bad time, because once again, if I change my XY, then I also have to be cognizant of my Z's and change my Z's so that my Z tilt adjust works the same as well. So that's why, irregardless of which way I mount the door, so that we can see our backpack, it's going to be, I'm not going to change my XY and all that stuff. I want to get it moving and then potentially go through and think about, really sit down on paper and go through how would I make all the necessary changes across all the macros and everything else so everything would work right. And that's what I'm saying. It might just be easier just to have it, quote unquote, cattywampus. Okay. The other thing, so normally, so this is the backpack, your door would be right here. So you would run your cables down the sides. Well, when you rotate the backpack and you put your door here, that means you're either running your cable right through the front of the glass, so the visible side, or you run it all the way around the back, in which case this cable is going to be too short. So I'm still thinking about running it through the front. You would probably only see it right here and right here as I bring it up onto the metal piece to jog it around the back. But I'm not going to worry too much about that. And speaking of which, let's kind of go ahead and get started. You'll see I do have the umbilical in place and I've got the beacon wiring in place. I know I did that off stream. Part of what I was doing was trying to figure out where I can mount this distribution board so that I can make my runs a little bit nicer, and where I was going to have the beacon cable, because the beacon cable kind of needs to run with the umbilical. And then, yeah, so just trying to make sure I know where everything's running to get it more efficient. Okay. So with that said, I think I'm going to want to start with our motor wiring, and I'm going to start with the first motor in the back here, or actually I'll start with these two motors in the front. So this is the X1 and the, I'll say it's going to be our two back motors would be X1 and Y1. So I'm just going to undo these, bring them through. We are going to cut them and re-terminate them into the shorter lengths down the road. Right now, I just basically want to feed them through, and then we will plug them in. We'll just feed them through, wrap them back kind of up a little bit, and then plug them in. And I will cut them down a little bit later after I can verify that I've got good movement. And really the only reason I don't want to cut them down beforehand is if I decide to move, change the placement. I guess I can still. And we'll keep them long for now in case I do decide that I want to change the placement of the boards and move boards around, right? I always had a thought of just running these boards side by side and then running power stuff down here. And I mean, that's the way I had it. I'm trying to remember why I changed it. And I can't remember off the top of my head right now. Yeah, can't remember off the top of my head, but I did move it. So I don't think the Constellation board is going to move. If anything, this board would move. So my Constellation is most likely going to stay where it's at. My beacon cable here, it's a 6-foot long cable. It's way too big, but before I even think about cutting it shorter, I need to make sure that I've got the right connectors for the beacon board side. And then I can cut this probably a lot shorter and make it a shorter run. They give you a 6-foot long cable, so, and we're saying that this is X1. And X1 we have going into what, stepper? Dang it, I didn't bring that up. Hold the thought real fast. Constellation. Yeah, so X1 is going into stepper number 2, which is top right here. So X1 will go into stepper 2. Y1, again, I'm going to have to open these up to pull them through the grommets. So this is going to be Y1. Should be in motor 4. Which will be 1, 2, 3, 4. So this is the bottom one over here. And so what I'm going to do is just try and get these in place so that I can run a stepper buzz and make sure that everything is working, everything's going in the right direction. And then from that, I will go ahead and start cutting these down to size, doing some cable management. And this is Y1. Oh wait, this is Y. Y would have been into, no, that is Y. Y1 is going into 4. We got X1. X1 goes into motor 2. Y would go into stepper 3, and that's Y over there. So this would go into stepper 3, and Y1 would go into stepper 4. That one will go there. This one will come down and go here. And then X, which is over here, will come in and go over there. Now I do have some wire channel that we printed out, and it's a strange multi-part wire channel, but I will work on getting that put in place. It should fit right up here at the top and allow me to do a little bit of cable management. And then as far as putting stuff down in the channel and making it all pretty, I do have some stuff that will do that as well. So X at the top, X and 1, X1 and 2, Y and 3, and Y1 and 4. So that'll be those 4. Okay, Z motors, we're going to be basically doing something very similar. So Z1, once again, is the, so we've got Z, Z1, and then Z2. So we're going to kind of pull these through and do the same thing with them, but we're going to go into the lower board. And the way we designed that, or we did the configuration for that, is the Z0 will go into the our first one. So Z or Z0 will go into the first one. Z1 will go into the second motor, and then Z2 will go into the third motor outlet. And I kind of want these long a little bit, but I don't want them super duper long. There's one, the middle motor. This is going to be the rear motor. Is going to be the next one in line. Once again, we will shorten these, recrimp them, make them all neat and pretty down the way. Right now, we're just going to get them in. So that we can do some initial testing. Thank you for the follow, due to late too. Appreciate it. And we'll also have to do a little bit of cable management and stuff like that. So on our lower piece, and I'll show you what I mean here in a minute. There is there's a bottom cover, but there's not a deck panel, if you understand. So there's a bottom electronics cover or bottom printer cover that will cover up the lower part of the printer between the printer and the table. However, there isn't a panel that goes over the Z motors. And that's because the Z motors themselves, the reduction gears, stick up above what the bottom plate would be. All right, that's what jacked up, but we'll put that in place into the next motor slot. So there we go. I'll bring you guys in a little bit closer. So this is X, X1, Y, Y1. So our motors go 1, 2, 3, 4 on the constellation board. Then down here, we're going to have Z, Z1, Z2. This will be our extruder gear on our tool head. Now this is not CAN bus, this is an umbilical. So we'll need to bring all of these wires and extend them down to the board for those that we're going to be using. And once again, there's a couple of things in the fact that the fans, we've got 24 volt fans, but currently it's configured based on soldered jumper pads on the carabiner for using the alternate voltage, which would be 5 volt. So we'll need to fix that before we can get the fans running at the right speed and temp. We haven't installed our bed yet. We don't have, of course, our thermistors or anything like that installed. So we'll need to make these jumpers to go down here. That includes the motor, the fan wires, the thermistors, etc. Now, when we go and do that, the hot end, it's imperative that you pay attention to the polarity of the hot end. And a lot of people will go, well, there's no polarity requirements on a hot end. And you're correct. However, because we're using that 24 volt to provide 24 volt to the tool head, there is a requirement. So if I was using 5 volt fans, no worries. Wouldn't matter. But because I'm splitting off the 24 volt to power all the fans, if I get the polarity wrong between the tool head connector and the tool head power down here, remember 24 volt is constant on your, well, the power pole is constant on any of your plugs in your screw down terminals. It's switched by the negative side, or the quote unquote pin side. So PA2, whatever. So that's why it's critical, is if you're if you have the positive side of your carabiner board, your distro board, going to the negative pole on your heater, then your fans won't work unless your hot end's fully powered on. Which means as soon as your hot end shuts off because it's doing a PWM cycle, your fans will shut off mid-print. So why didn't I choose to use CAN bus? This kit came with the carabiner board and the distribution board, and the design philosophy of Annex engineering is to use USB and not use CAN bus. That's why all of our boards are connecting and talking over USB serial. And a lot of that has to do with the bandwidth limitations. You're never going to overrun the bandwidth limitations on a serial USB connection. Also, when you connect via serial, you don't have to set up a CAN bus network. And as you saw when we were doing Chewy's build on Saturday, everything in the CAN bus network has to be set to the same speed. If you set one of them to a different speed, then it's going to be broken, and you're going to have to go back around and get your firmware rebuilt and reflashed. And so if you guys checked out Saturday's stream, I haven't published the VOD yet, and I haven't pushed it to YouTube yet, but I will. I will say, let me switch this up so that you can see me fully. I will say that is the first time that I have flash cam boot or catapult and then flash clipper, and everything worked right the first time and I didn't have to reflash anything. So knock on wood. It was the most simple CAN bus installation that I've ever had. So take that with a grain of salt, take that with for what it's worth. But it was the most simple CAN bus install that I have done. And so one of the things that I want to show you, there are people that are putting the, switch this back. I'm going to turn this around. So what I have seen is people that are putting this in cable sleeving and then putting some tie down points here and just tying down the cable sleeving. What my plan is I'm just going to use this 2020 cover stuff, slot cover, and I'm just going to take this, line it up, push this down in there to hold our cable in place for the length. We'll have a little bit of a gap right here as our cable has to have a spot to go down into the 2020 slot. And then over here at the end, I'll of course need to cut this to have a little bit of a gap so it can pop back up out of the slot. And like I said, it'll route around here. With the door here, I know that there is some etching on the door. So I'm not too concerned with whether or not you can see this cable. And if I decide I need to, I can add a little bit of the cable sleeving right around that. But I'm not too concerned, like I said. This is just going to hold this down in place. I'm going to crash bang. I'm going to do this on both sides real fast with these. It's just pretty quick and easy. And hey, Daddy Wazzy, how are you doing, my friend? Welcome on in to the Dragon's Den. Glad you're doing okay. I hope you had a good New Year's. You had a good New Year's. And I may go through and just do this on any of the exposed rails just to provide a little bit of, just pretty it up a little bit, I guess is what we could call it. I don't want to make it too tight though. I do want a little bit of strain relief on these motor wires. I know some people will pull their motors real tight, and then before you know it, your motor wires are failing, and where they fail happens to be the solder joint at the motor side. And let me just tell you, it's not fun because you actually have to take the motor apart and get in there and clean up the solder joint and re-solder it. It's not hard, but it's just not a fun task. We'll put it that way. And just like that, we've got a little bit of our motor routing done. My thought here is I may run one across the top in the same type of vein, one across the bottom, or one here. But at the same time, there's going to be a plate underneath this. And then there is a printed deck panel that you can put on that kind of covers up this bay area. So you really don't have to like go, I'll say hog wild crazy with your wiring down here. So I probably should have ran this one underneath rather than above, because you'll have space underneath the You'll have space underneath the extrusion, not above the extrusion if you put a printed piece in there, because it will sit right over the top of the extrusion. So let me fix that faux pas real fast. Pull this one back through. Bring it up underneath the extrusion. And I will have to sleeve these definitely as it comes through the grommet, just to make sure that we don't damage the wires any, and to just kind of keep those 3 motor wires kind of as I don't want to say as far away as I can, because I'm not going to be able to do that, but kind of keep them as neat as I can to get them around the 110 voltage for the heated bed as much as possible. And really we're going to make the motor wires as short as possible, and we're going to keep them twisted as much as possible, because that's what's going to help with any EMI or electromagnetic interference, is the twisting of the cables, especially as they're around the PSUs and the 110, which was originally why I wanted to keep these as high as possible. And it would give me an opportunity to route the all the power still in the middle channel of the board. Now I'm kind of questioning to myself again why. Hold that thought. Move that, move that. Bring this over here so I don't get it. We're going to lay this down. Now that we've got our motor wires done, we're going to lay this down. I'm going to plug this in. And we're going to work on building our wires from our Karabiner distribution board here down to our SKR 3. So I'll kind of move this over, raise you guys up a little bit so I can give you a better downward angle at what we're working on. So once again, this will get cleaned up. I'll bring it up and sleeve it around as best as possible. Maybe put a little cross tie here so I can tie things up. We'll also be bringing the 110 voltage right up here. And that was kind of my thought before, was this board sits up here. All my power connections would be on this side. But then I'd have to bring the bed wires up and over, which was still making it a little problematic for the wiring. And then I could also keep the 110 more down here. And once again, the possibility of putting a DIN rail there for the whatchamacallit, the SSR and the, I don't know. I keep talking to myself about which way I want to do it. I'll probably change the wiring up like another 3 or 4 times, but we'll see. Right now, we just need to bring in some wiring from our carabiner down. And once again, we just need to pay attention to how it's laid out and what the actual polarity is, because polarity is definitely required on the hot end power. So we're going to come back here. Let me go over here to the, actually, let's go back up here to the browser window. Change that to that one. So what we're going to be looking for here is the Annex Engineering PCBs. And in here we'll have the Karabiner series toolboards. And we need the distributor. So if you look at the Karabiner, once again, it's a different setup because they make different carabiners, which is the tool head board. And these are primarily made to mount onto the tool head of the K1 and K2. There is a specific one for the K3. And this is where I was having to take a quick look around at the wiring guides here. And you'll notice, so down here on the bottom right, which is off the screen, let me go full display real fast. Keep an eye on chat. Love the colors of the build. Yeah, so the build colors here are the Sparkle Obsidian Black and the Sparkle Limebot Green PCABS by Sparta 3D. So what you'll see here is the front side and back side of the tool head board. Once again, the same connections are available on the Kerabiner as in the K3 Biner used on this build. They're just, it's a different placement. But what you'll notice here is like part cooling fan main, part cooling fan alt. So on the board that I have, the PCF main is not soldered together, but the two pads for the PCF alt are. Same goes for the hot end cooling fan, which I'm trying to find on here. Where's the here we go, HEF main and HEF alt. So what's happened is both of mine are soldered up for the alt, which means it's 5 volts. All of my fans are 24 volt. So I need to go and remove the solder from those pads, make sure they're fully cleaned up, and then solder the two pads between PCF main and the HEF main to make them the 24 volt that we're feeding to the hot end. Okay, so that's kind of what I need to do on my carabiner and why I need to take it apart. And that's also why, once again, the polarity on my tool head board, my distributor board, going into the hot end is paramount because that's what's feeding these thicker gauge wires right here. These first three are hot end voltage, hot end ground, and then alt voltage, which is the 5 volt. So that's why these first three here are a heavier gauge, is they're going into, they're providing the positive and the main ground. So that's where we need to make sure that we're sending the right voltage in there. So that is the carabiner, the tool head board. So what I need is the distributor or the distribution board or distributor board. You may see different connectors. So like right here, you're seeing everything is JST, but you'll see that a couple of these are not JST. So this one, all the way down at the bottom, in the middle, and the middle are shown as JST, but they're not. They're microfit connectors. which are higher amperage connectors. And you'll kind of see that in this board layout here, where you're seeing different connector types for that middle row on the left side and right in the center. Those are those microfit connectors. Okay, same thing that you're seeing here is the microfit connectors. So what we need to do is just make up our connectors to make the wires go from here to the tool board. We'll make them a little bit longer so we can probably sleeve them kind of like the umbilical is, bring it down here and then break things out. I don't know, we'll see. We'll sleeve it if it makes sense. Oh, CT and an MRI hybrid robotics. What's going on? So I've dropped a few frames. There is a little bit of chop, and I am noticing some lag between what I am seeing on the stream and what's showing up in uh, my monitor or my dashboard, which I do run on a second computer and on a different network than my streaming PC. So I run my streaming PC as the only thing on my second 5G channel, and majority of my printers are set up for the 2.4 network or the darn it, is set up for my 2.4 network or the uh, first 5G channel. Darn it. This one. That's right. Pull this up just a little bit more so you kind of see how I'm looking at the connectors and basing everything. So I kind of want to look at this because this would be the backside, which will help me identify which pin is where as I'm starting to do these installs. It's silk screen on the front as well, but sometimes it's not as clear on the front. So in my hot end, the positive is towards the 16 pin connector here. So the positive is here, the negative is on this side. Once again, we just need to be aware of that and cognizant when we do our wiring. And when I'm going to do these hot end wires, I want to be using, this is 24, yeah, 24 volt. So I do want to be using probably 20 gauge for the hot end wiring. And, I was going to open up new ones, but I think, yes, I've got 20 gauge already opened up. So I go over to KB3D and I get linear wiring. So 20 gauge is the smaller size, 24 gauge, I believe, is the bigger size. And I'm sorry, this is 18 gauge and 24 gauge wiring that I've got here. So I've got 18 gauge red and black, 24 gauge red and black, and then some 20 gauge red and black. You're going to need at least 20 gauge. Looking at this is supplied in the umbilical though. I can't tell, but that may be 18 gauge. We may run 18 gauge for these. Just to be on the safe side. I did check, actually no, 20 will be fine. I did check and do a evaluation. So when I'm running my power to both boards, whether it's 24 volt or the 48 volt that comes up to the Constellation, it is running on 20 gauge wire because I spec'd out, I did some calculation to figure out 48 volt max amp of this PSU up to this over this length, which is like 30 centimeters. I think it's like 28 centimeters. And it said 20.1 is fine. So I was like, okay, good. Did the same thing for the 24 volt. And so everything I'm using here is 20 gauge. So we're going to continue to use 20 gauge. I don't really see a need to up it to 18 gauge for this area. If you guys think there is a requirement, let me know. And I'm going to make these long because I can always cut them shorter, depending on if I need to, after I do some additional cable routing. I'm just going to lay these out and get our first positive and negatives made for our hot end wires. And what I tend to do is just kind of eyeball measure out one and then use that to pull the second wire so that my positive and negative are the same length. And then we'll work on, in this case, doing a microfit connection for these two wires. So it's a microfit 3 on the one end, and then the other end, of course, will be ferrules that will go into the HE1 or HE0 slot on the board. And then you let it completely unwind. So there we go. That's always good. At least it's wire and not a filament spool, right? I get trying to keep things nice. Yeah, it could be part of you. Why not? Because I haven't quite figured out if it's my internet or if it's the internet or some combination thereof. My internet, I mean, I'm semi-rural, so I don't have great internet. It's pretty subpar. I've got a 100 meg up and I'm getting, or excuse me, a 100 down, and I've normally been getting like 20 something up, which isn't the best. It's not the worst either, but it's just kind of subpar. The But I know some people have been complaining that there is been some crap internet and some crap Twitch. So I don't know if it's Twitch, if it's OBS, if it's my internet or what have you. I just know that I can see that I am dropping some packets here and there. So kind of the best I can give you right now as far as what's going on with the connection. But I do tend to really like the Lineo FEP wiring. It's definitely going to have the higher temperature rating. It's going to be good quality wire. So definitely like going with that. Once again, these are microfit 3 connectors. So once again, from KB3D, they've got a Molex microfit 3 kit. It's always good to have. You may get some connectors and 2-pin connectors in some kits for various boards. I found it was always good to have a couple of these on hand. So I just made sure and got one. I definitely tend to make sure that they fit. And then once I get my connectors laid in there, I'll be able to sit here and think through, okay, which one goes where. And definitely make sure whether or not you need male or female pins. Hey, Shenanigans, how's it going? Welcome on in. You had a CT on your chest and an MRI on your right shoulder. Um, you have had bad breathing issues since I was in the last shelter. Oh, not good, my friend, not good. Hopefully everything's good. Um, yeah, I know when I found out about my right shoulder, I had reached up to grab my mouse at work and I lost all feeling in my right arm. And of course, immediately it's like, oh my God, is he having a heart attack? You know, and it wasn't a heart attack, thank God, but it was a pinched nerves in my neck. So I wound up having neck surgery after determining that, um, was it C4, C5, no, C5, C6, and C6, C7 were both blown. So I had C5, C6 replaced, C6, C7 fused. And then we also determined after that was done that I also had a torn labrum in my right shoulder. So I also wound up having a labrum repair on the right shoulder after the neck surgery was successful. But yeah, the scariest feeling was sitting there at work and losing all feeling down your arm and not knowing what was causing it. And then yeah, there was after we got the nerve issue squared away in the neck, then it was more of just pain in the shoulder and the arm, which of course was from the labrum tear. Once we got the pain receptors working again in the neck, and the rest kind of fed in. So I feel you, I empathize, and I hope they can figure out what's causing it and everything gets better for you in this new year. You know, and at first you sit there and you go, okay, so which is worse, the no feeling or the pain? And quite honestly, I think the no feeling is worse because you don't realize that there's pain and you can be doing more damage to your body because you don't feel the pain. So that's kind of how I look at it. So once again, looking at our the back side of the board here, the positive side is towards our carabiner. Just kind of validating that yet again on the board. So hot end positive, hot end negative. So the positive is towards the top of the board. So our red connector is going in the right hand side when you're looking at it from the clip. And then, or excuse me, our red connector, and then our black connector is going on the other side. And we'll go ahead and put that into our microfit connector there. Then we'll need to strip the other side and get it ready for some um, barrels. And we'll route this into, since this is our hot end, we'll go into HE0. Okay. We'll grab our other connector types here. Yeah, my brother's been dealing with that. So my brother had been in an accident a couple years back, and he had gotten hit by a deer on his motorcycle at like 5 a.m. in the morning on his ride into work. And he's had issues where he doesn't feel his legs from like the kneecap down. And so he's been getting a lot of swelling and stuff like that that he just doesn't realize because he doesn't feel them. Right. And so that's led to some other problems as well, that he's been having to deal with. But yeah, it's basically let's pay attention to our bodies and take care of ourselves in 2024. So the thing with FIP wiring is the amount of insulation is a lot less than silicone, and it's um it's just really really slick. So more often than not, I kind of get a little bit of a stretch rather than a clean um, uh, shaving of the insulation. So there's our negative, our positive. We do a little tug test. And now where we're going to go into E0, which is right next to our DC in. And once again, this is polarity specific. So we got to be careful there. And negative is towards our USB connector. So we'll come down, we'll put in our negative first, our black connector. And then we'll come in with our red connector. Give both of those a tug, make sure they're nice and good in there. And that will be our first connector. What's next? We're going to need our microfits as well for our thermistor. So we'll need some thermistor. And what I would do is if you happen to have cut some thermistor before, you can either do any type of like 24 cable, or what I'm going to try and do is grab some wire from a previous thermistor that I've had that I just got in here. What we got. This should work fine. So once again, just standard thermistor. This is blue thermistor wire that I have had from a different build. I'm just going to strip the one end, get microfit on it, and then we'll worry about the other side, which will be JST in a little bit. And this is probably 24 or 26 gauge wire. And it does have, this is a slight fiberglass insulation on this. So make sure you're down to the bare wire and get anything else off of it. Any little strands that get left. But you're good on the wire. I don't know about you, but any type of insulated wire like this, or thermistors or hot ends, I either get a clean wire strip, or I get all kinds of little shards from the fiberglass. Kind of drives me a little bit nuts, but it is what it is. And these are very fine cables, so you may have to double crimp these just to get a really good connection on the cables. We do a larger size and then go in and do a smaller size and then give it a little bit of a tug to make sure that it's nice and good. That's good. And at first you would say, okay, well, this is a thermistor wire. Once again, it's a resistor. We shouldn't have to worry about it. I'll say they do mark polarity on it. I'm going to be cognizant of the polarity just to make sure that there's no issues with it. Because once again, we're going through a distribution board. I don't want to have a chance of something being polarity specific and then kind of getting caught out when I fry something. So be a little cognizant there. Let's get any frays of the insulation material out of the way. We've been, sorry, I gotta go mess with the AC. We've been working with our crimping here for a couple of streams now. So let's just say we're getting good at it. For those of you that know, I am going to be working with Creatix Brit on a droid build of some sort. We're still trying to make final determination on which droid we're going to build. But I think what we're going to do is we're each going to build one and, kind of do like a his and hers or light and dark set that we will be bringing to 3D Printtopia in the fall. And once again, been looking at those and going to be lots of crimping as well in there. So let's just say I'm getting my crimping practice in now. And hopefully we can retire our crimping ain't easy shirt in the near future. So we got our wires crimped on the one side. Once again, we're going to see how this goes on and clips on. Okay, and so the side closest to our board for the thermistor would be, we'll say, like the hot end and then a ground. So what's the designation on the other, on the actual board? This. Oops. I need to see our board pinout, which is a different window, of course. So change the view for you guys so you see what I'm looking at. So looking at the board pinout for the thermistor, and this is the thermistor for TH0, we have a ground pin and a PA2 pin. So we have a TH ground and a TH HE. So thermistor for the hot end and thermistor ground. So the thermistor hot end would be the side closest to our SKR board, and therefore that is the one that is going to the pin designator. So that will go to the PA2, and we're over here. So the PA2 is closer to the mounting hole for this side of the printer. So we're going to come down and it's going to go into this side on the JST pin. We're just going to kind of figure out how long we want to make it. Yep. Give it a cut, and we'll make the other side or the other wire match that length. And then once again, the side closest to our board is the HE. So that's the actual switching pin for the thermistor. So that's the one that we want to go to our switching pin or our designated pin, our PA pin. Or JST connector. I don't think we're going to need our ferrules anymore, or at least not in this section. We will when we go to the bed, possibly. Yeah, we will have at least one or two on the bed. So put these away so I don't knock them over and have to clean up and sort out ferrules, because that would make for a great stream, wouldn't it? Okay, so we need our JST connectors now and a 2-pin JST connector eventually. Go ahead and get these crimped on now. Yeah, because they're combining like grounds, so they're doing some common grounds, and they're doing definitive switch pins that are pushed through the carabiner. You definitely want to make sure that you are paying attention to polarity, even on the things that polarity normally wouldn't matter. Once again, such as our thermistors and heaters. Besides this, how's everybody doing? I hope everybody had a good holiday season and had a good and uneventful New Year's. I hope. So now we're going to take our 2-pin JST connector. We're going to be looking and saying, okay, our switch pin is towards the right side of the connector. Connector goes this way. That one goes there. The ground goes on the left side said connector. We'll bring that down and plug that in. We're going to need to extend our motor out. And since it's a motor connector to a motor connector, what we're going to do is just grab a motor wire that we had cut previously and shortened. So boom, there's a motor wire that we had cut previously and shortened. And we're just going to use that because it's going to be a direct motor wire to motor wire. Make sure that this is pinned out the same way. So red, green, or excuse me, black, green, red, blue. It is. That will be on that side. And we skip one connector because the third connector on most boards has a parallel connector to plug in two Z's. So we'll split that. Come over here. We'll probably cut it right about right there. And we'll be able to repin this end now with JSTs. And once we get these repinned, we'll figure out what our pin out should be. And we'll just strip them and pin them and then verify our pin out. And the nice thing about having that distro board, kind of like we've got on our V0 with the pike umbilical or the V0 umbilical and our Vorons and stuff like that, is we can unplug that one main cable off the tool head and then disassemble our tool head without having to worry about, you know, a lot of wires that are home run that are now getting all over the place as we're trying to disassemble our tool head. And solar, good drop for 75.82. All right, 1 cup of coffee down. Okay, had to take the puppy for a walk. Good. How's it going, solar? Some of our JST connectors popped off here. Yeah, I am finding that I've bought so many Big Tree Tech boards and there's so many JST connectors and other types of connectors that pretty much I don't need to buy JST connectors anymore. I may still need to buy some like microfit specific microfit housings, but JST, I'm good. Gotcha. So your PT didn't get started over the break, so you're probably gonna have to do it now that I'm sure that your doctor was probably shut down a lot through the holidays, at least the PT place. So okay, hopefully you can get your PT going and get some of that squared away soon. I know that's the part that really sucked, was just getting back in and doing PT and trying to get things moving and feeling like they're human again. They wanted you to wait? Okay. That just give it more time to start healing up some before they start trying to get you some range of motion and stuff back again. Well, no, it's weird depending on which doctor you have, and of course, once again, how traumatic the surgery was. Um, like I had neck surgery, and it's like, okay, you're convalescent for 45 days, and then you get to start rehab, right? And then it's like I had my knee, and they had me up and walking that afternoon after surgery. Same thing when I had my gastric bypass. The next day, they had me up and trying to move around, which is good because they found an internal bleed. Because every time I'd start to get up, my blood pressure would crater, and they realized that I had an internal bleed, so something that didn't seal up right. So they had to go back in and do another surgery, which sounds a lot worse than it truly is. Um, excuse me. So we're 1B is the black. Okay, and on our Karabiner board, I just want to see like how we're 1AB, 2A, 2B. Okay. So this is 1B, 1A. So I'm going to match up the letters 1B, 1A. So JST connector here. B in the middle, 1A. So on our connection to here, we go 1B, 1A, 2A, 2B. So black is 1B. 1B is have the right connector loop. So 1B, A, and then 2B, 2A. Yeah, so here, because we're trying to match up, these aren't, this isn't a full home run, so I'm trying to match up the pins. So what would normally be expected, so all the way all the motors plugged in, they're all going to be lined up the same. So I want to make sure that this is lined up the same pin wise. So 1A to 1A as a straight through, because that will allow me to say, okay, it should be phased right. And it's just a matter of, is the direction right or wrong? So hopefully, fingers crossed, that works well. So I've got the hot end, the thermistor, and the motor connected in. This, can't see there. The 5-pin connector here on this far side is for the probe. We're not using that because we're taking the beacon straight back. We may wind up using this for the end stop if we add the end stop to the tool head for a filament runout sensor, which we would then use for our trad rack, which is the Annex Engineering's MMU. So we have our part cooling fan all the way over here on the left. We'll need to do our part cooling fan next. And once again, we're just going to be using some probably 24 wire for the part cooling fans. We don't need anything more than that. We got some 24 prep wire here. We can use silicone wire if we had silicone wire, which I think I've got. Should have some 24 gauge silicone wire down there. Nope, 22 gauge. So I got some 22 gauge silicone wire down there. Got all kinds of wire in here. We'll go ahead and we'll use our 24 gauge prep wiring. And I'm going to use, let's see, what do we want to use? We use yellow and blue and green and blue. So like I'm going to use the blue as the ground. Is that right? No. Blue's always going to neutral. So yeah, we'll use blue for the ground and the yellow or green for the signal because we'll have a part cooling fan and a hot end fan. That'll just be easy enough to use one way or the other. So once again, we're just going to kind of figure out some gauging between, or not gauging, but some length between our pinout and where our fans go. Figure out a good distance, make the cut, and then I'll need a green and then 2 more of the blue at that length. So this wire that I'm using is just FEP wire off of Amazon. It's worked well for my builds so far. And then I recently started grabbing, Lineo as the known good wire, so to speak. So, I really, 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 really like the Lineo wire. Just very good quality. And I know what I'm going to get, and I know it's not going to be crap. So if this was going in the actual, heat chamber side, I probably would be grabbing the Lineo. But since this is in the backpack side where it's going to be cooler temperatures anyhow, I'm not as concerned. about using this. And once again, on this side, since it's going to be jumper wires non-moving in the lower temp side of things, doing it with whatchamacallit, silicone wire would be perfectly fine. Yeah, happy Annex Day. Hey Zombie, how's it going? How is the how is your tap changer project going? I believe you had it pushing plastic on a single head on your last stream. If I remember right. But have you built your other, what, 5 tool heads yet? And so what we're doing here, Zombie, is we just we're doing some quote unquote basic wiring to validate functionality. And what I mean by that is we've got all the excess in here, right? I haven't cut everything to length and made it pretty yet because I just need to validate configuration and that things move and that there's no major issues. Once I get that done, then I will go through and pretty up the wiring, which I may do during this week because I'm off this week during the day, and I'll probably just jump on and stream while I'm doing it. Kind of just be a ASMR chat and chill wiring stream in the middle of the day because why not? And who knows, I may even, depending on how I feel when I start doing that, I'll work on getting these wires trimmed down. And then I may also work on some of the additional wiring on Chewy's 2.4 build, just because. Not on the tap yet. Just, okay, so you've just got it up and running on a straight dragon burner. Nice. So, yeah, where we're at here is I'm just building out the, we'll say the jumpers between the Karabiner Distribution board and the SKR 3EZ board. And then, like I said, I'll work on cutting down all the various motor wires and cutting them to length in a later stream after I validate functionality. Like printer moves and goes burr. Yay! So, and one of the things that I learned while reading in the forums is that certain pins on the distribution board are um, are polarity dependent. So normally on your hot end, you could care less about the polarity. But because we're going through a distribution board, we need to match the polarity identified on the distribution board because it's a switched power circuit, right? So the negative side or the positive side's always providing 24 volt, and the negative side is the switching factor on your hot end and your bed. Well, because we're using the hot end 24 volt lead to provide 24 volt to the carabiner, if you are not polarity conscious, you're going to continuously shut off 24 volt power to your fans, right? Because it takes 24 volt off of the hot end if you're running 24 volt fans. If you're running 5 volt fans, then it would be taking the 5 volt feed from the board. Well, right now, the other thing is my carabiner is currently wired, or I should say the pads on my carabiner are set up for alt power for the fans, which means it's providing 5 volt to the fans, and all of my fans are 24-volt fans. So I've got to go in, take the Sherpa Mini off, and desolder the um, hot end alt power or hot end fan alt power and the part cooling fan alt power, and resolder to jumper um, the main power voltage to get them at the 24-volt power. So that I probably will not do on mainstream, but see, may do that on one of my days where I'm just sitting here and not expecting to have a whole bunch of people in the stream, because I will be focusing a lot more on that when I'm doing it. Because hopefully I can clear those pads and resolder them without having to take that board off. But I may have to take the whole board off, which means disconnect everything. I mean, it's not too bad. It's just disconnecting some cables, but just sucks having to do it after we got our tool head put together. But soon we'll be having 2 printers moving under their own power. And then the next step will be getting them all tested, um, getting the um, basic tuning done on them, and then we'll get them paneled up. And then, of course, we've got a couple of more builds to do on channel going into 2024. Yeah, Rook and Bugbo are about the same entry cost, but your Rook is a 120 by 120 and your Bugbo default is 235 by 235. So, it depends, and it may also depend on what spares or stuff you also have on hand. And I believe the Rook 180 was actually designed around a Prusa mini bed. So if you got a regular or a cloned bed, you should be good for that build. Retail Hiren, welcome on in. Nope, don't need any promotion. Yep, you are a bother. Hey, Creatrix Brit, welcome on in. Well, it's about 6 o'clock, so we've been going for a short bit here. I started a little bit early today just because, well, I'm off work, and I figured why not start a bit early and say hi to everybody. So welcome on in, everybody. We've been going for a couple of hours. Nick, Hydra Robotics, Modlight's here. Modlight, if you could throw some shout outs, that would be great. Zombies showed up. Creatix Brit showed up. And hey, Modlight, by the way, I didn't see you sneak in earlier. So we've been working on some additional wiring for the Annex Engineering K3. Let me go ahead and fill that up here. So we're keeping everything long right now. So we've got our 3 Z motors pulled through. We've got our X and Y motors pulled through that are going to our constellation. We had our carabiner umbilical in, and we've got the super long, because it's a 6-foot USB cable for our beacon probe. I do not want to cut this yet. And when I cut it to size, it would be cut to size on the tool head side, and then I'd have to repin it. And I don't know if I have one of those connectors. It's a different connector type. It's basically still a JST style crimp, but it's a different physical connector than a JST connector. So I just need to make sure I have one of those before I try and cut that cable shorter. But right now we're just kind of laying everything out. We're making our connections from our umbilical distribution board back to our main board. And yeah, that's kind of where we're at right now. And one of the things that I have seen that we needed to definitely be cognizant of is because of the way the umbilical brings like power from the board up through the umbilical to the tool head, we need to make sure that things that we normally wouldn't care about as far as polarity, like our positive and minus for our heater, we normally don't care. Well, on this, we do, because this is how we're bringing 24 volt to the actual tool head. And you always switch on the ground for these for your PWM. So if you get these reversed, all of a sudden your fans will just like shut off at random times. And it's because your heater has reached temp and it shuts off until it needs to warm itself back up again. And so you'll see a lot of pulsing in your fans and undue wear in your fans. So that's where we need to make sure and keep our polarity right. So we're going to keep that going. Same thing with our thermistor for our hot end. We made sure that that was pinned out right. Our connector for our extruder motor, we made sure that the 2B pin on the controller board is matched to the 2B pin of the distribution board, because all of our other wires we brought back directly from the motor to the from the motor to the board directly, so that we kept the same color pinout. May give us an easier chance at not having an issue with our extruder when we go to plug that in and check for movement. But yeah, so now we're getting ready to do our jumpers for our part cooling and our hot end fans. So we're going to bring those over and get those connected in. And I've decided to use blue as their ground pins or the switch pins. So if you look at your fans, the fan connectors, where are my fan connectors? Fan connectors on the pinout. Okay, here they are. So the pin closest to the motors is the voltage for the fan, and the negative or the switch or the pin number is to the right of these JST connectors. And that'll be critical because right now all of our fans are set to VN, which would be 24-volt fans, which we do have 24-volt fans. So that's something to be aware of as well. We want to make sure that we're getting the voltage through the right pin. So it's going over the right cable, going to the right part of the carabiner board. Because once again, if you get those switched, then it's trying to switch on the power side versus the pin identifier. So just need to be aware of that. I need some 2-pin housings, ST housings. And once again, on our fan side, the ground, which is going to be my blue, is this direction. So it's going to be on the right side of my JST connector. I'll set both of those up. And we'll get the, we'll just put the yellow on the left side of one and the green on the left side of the other. Doesn't really matter what order it is just yet. And we have V0 at the top, then, or excuse me, fan 0, fan 1, then fan 2. So we need to figure out which fans are which in our configuration file. And I need to go back over here and look at the Annex engineering, we'll say the configuration. So what I'm going to do is, so I've got one page up that we're looking at the Karabiner Distribution board so we can figure out the polarities here. But also we need to come over and look at the Annex engineering repository for the firmware. So they have a repository specific to firmwares. And Clipper firmware. And in this case, we're going to look at the K3. The K3 was set up to use a spider board in this configuration because it was provided up by Tails. Don't worry about that. What I'm going to be doing is looking at which fan goes into fan 0, fan 1, fan 2. So I'm going to scroll down here till we get to the fan section. We have cooling fan, which is the nozzle. But for sure they had it listed as which fans they were. Darn it. Connected to fan 0 on the spider. So the fan 0 should be our hot end cooling fan. So fan 0, hot end cooling, we're going to use our green cable for that. We're going to plug that into fan 0, which means this is going to be for our hot end cooling fan. And our hot end cooling fan is this second connector from left to right. And our negative is on the right-hand side of that connector. We'll grab another 2-pin JST. Once again, we know our negative is our blue. You want how that slots in there? We'll grab the blue to the right-hand side here. And we'll go on the other side. And we'll bring this over and plug it in. And then our other wire, which will be our yellow wire then, our yellow and blue pair, will be in the second fan slot, which is fan 1, and that's going to be our part cooling fan. And looking at our part cooling fan, once again, the negative is on the right, so our blue pin will go on the right side of the connector, and our yellow will go into the left side of the connector. We'll just bring that over and plug it in to the distribution board. And what else do we have? We've got the probe, the chamber thermistor, which we don't have one installed. And what's the other stuff? So the other thing we have is alt. This is positive and negative for the alternate power. Got the part cooling fan, the hot end cooling fan, a chamber thermistor option, so we can put a chamber thermistor in here. I will probably do that down the road. So, all right, Solar, have fun with dinner. Can we turn off Retalihiron? We can. If they get to be annoying, how do I do that? Click on them and ban. Boom, gone. Retalihiron is gone. So there we go. You're printing tigers. Nice. Hey, Tech Jeeper, welcome on in with a party of 4, rated with a party of 4. Thank you so much. I appreciate that, my friend. Welcome on in. We are working. Let me switch scenes real fast. Grab a quick drink. So we are working on wiring up our Annex Engineering K3. We've been working on this slowly but surely. We did all of our 110 wiring first. Here, let me switch. We did all of our 110 wiring, which is down here in this quadrant, that powers a UHP 248. That is this bottom or farthest PSU. And this provides 48 voltage power to our Annex Engineering Constellation board, which is running all of our top gantry motors, our X and Y motors. Then we have a UHP 224, so a 200 watt, 24 volt power supply, comes into a distribution block and powers up a SKR 3 EZ board with 2209 drivers. This powers our 3Z motors for the bed and our extruder motor at the tool head. What we've been working on right now is taking our carabiner or tool head umbilical and connecting in all of our wires for that down to our main controller. Once we get everything done, we'll provide a nice sleeve for that and just sleeve it down a little bit to make it a little bit nicer. We still need to install our bed and put in our our SSR for the bed, which my thoughts are going to be mount it right here, right in front of the fans, in which case I'm going to mark the hole locations. I'm going to center punch those holes. Then I'm going to drill holes in my, this is an aluminum, like 3mm thick aluminum back plate. I'm going to drill holes in there and I plan on tapping them for M4 screws. And that will allow me to mount this SSR directly to a metal backing plate. And I can put a little bit of thermal compound here, and that basically makes the entire back panel a heat sink for the SSR. Then I've got a 24 volt to 5 volt buck converter. This provides 5 volts at 10 amps. I'm going to mount this probably just right there with some VHB tape, bring my 24 volt up and my 5 volt around into the, I've got a Waveshare 7.9 display and the Raspberry Pi 4B. So that will power up both of these quite nicely. Need to also put a little bit of not VHB tape, but Kapton tape right here on this piece. So I did have to modify this metal piece just a little bit because of some connectors right here, and I'm getting a little bit of interference with some jumpers. So I need to provide just a little bit of Kapton tape right there. I've got Kapton tape on the other side underneath the Raspberry Pi. Some of these wires I will make a little bit shorter and clean up a little bit. In fact, I'll probably cut this down. This is my feeder for the 24 volt. I'll cut this shorter and then use these wires to plumb into the 24 volt side. But yeah, we're getting close. We're getting close. Oh, nice, Tech Cheaper. What kind of board and what kind of laser were you running? Hey, Tripod, welcome on in. Welcome on in. Hope you're doing good. Thanks for joining us. So we're working on some wiring. It's looking kind of snaggletoothie right now because I don't want to cut my motor wires down to size just yet. I'm trying to function check them, and I'll work on changing any pinouts that need to be done if I need to change some pinouts and stuff. And then we'll, at that point, then I will come back in and cut them down to size. I'll add some additional cable routing stuff in here, like I'll put a little bit of sleeving right here to make this a little bit nicer. Maybe add some tie down points just to clean up some wiring. I will probably do this soon, right next, because one of the other things that I have on this board is there's a part right here for alternate power, and that will provide a 5 volt connection up into the toolhead board. And we would need that for some probes or some other things. Right now, there shouldn't be anything that needs it, because the part cooling fan and the hot end fan are 24 volt fans. But right now, the toolhead board was pre-soldered up with some pads, and I will show you that here in a second. So the Karabiner, this is the toolhead board, and it looks different. Whoops. Yeah, actually, let me go full display here. So this is a different layout than what I have. This is the standard Karabiner toolhead board. What I've got is a K3 Karabiner or Karabiner for the design specifically for the K3 tool head, the cross XY tool head, or the Cartesian XY tool head that we use. It's got all the same connectors, it's just a different layout. With that said, you will see down here on that tool head board that you've got part cooling fan, PCF main, and PCF alt. These are just tabs, and if you solder the tab, if you solder this left tab, then it's going to pull from the main voltage, which would be, in this case, 24 volt, because it's whatever's going to the tool head. If you solder the other pads together, then that means you're using the alternate voltage, which in this case would be 5 volt or 12 volt, whatever you send to the alternate voltage pad. So right now, my tool head board is pre-soldered with the alternate voltage selected for both the part cooling fan and the hot end cooling fan. So there's two things that I can do. I can either one, pump 24 volt to the distribution board for the alternate voltage, or I can take the tool head, take the extruder off the tool head and desolder those pads and resolder them to PCF main. That is the best and cleanest way to do it, because the expectation would be you would not be providing 24 volt to the alternate voltage, knowing that you're sending 24 volt to the hot end. So technically I don't need anything going to there. I can pipe 5 volt to there, either from the main board, or I just do it from the from my 24 volt to 5 volt buck converter. I could do it that way, and that would enable me to then have at least some type of current going to the tool head fans. Because I think 5 volt, we should see something, like the fan should move, hopefully, maybe. Okay, so you have a K40 laser and you picked up the Monport board, so you can use Limebot. Okay, I've seen that. I've seen people do that a lot. And actually, I see people do a lot of changes to the K40 to make it more user friendly. But yeah, I've thought about picking up a K40 just to have a CO2 laser and be able to do more things. Right now, I've got a X-Tool D1 20 watt diode laser, which works out pretty well. Yeah, so at this point, what I'm going to do, I think, once again, we've got a pin out here for a chamber thermistor. So we could bring that thermistor down to, say, the TH1, and I can then add a chamber thermistor up off the board. So that's an option down the road. Or I can just run a chamber thermistor direct through one of the grommets and mount it somewhere off of the, extrusions. We can do that later on as well. We have, once again, a connector here that works for a probe or anything else that we want to plumb through it. We're not using that connector for the beacon because I've been advised not to, because there's a lot of interference issues if you do it that way. So yeah, I think we're pretty good for all the wiring right here. Let's work on, I'm going to spin this around so I can, I think I'll just move it towards me. I'm going to shorten this wire up, which is the 24 volt coming from the PSU to my Wagos. So I'm going to cut these, shorten them a little bit, and re-terminate them, and then use the cut ends to feed into my Tobson 24 volt to 5 volt buck converter. Once again, this will give me my 5-volt 10 amps. And I just ordered some USB-C power-only pigtails that I will then, put into the 5-volt side and run in for power of my Raspberry Pi. So that'll happen down the road as well. So let me kind of bring this forward or towards me some. And once again, I'll figure out a good spot to cut these. Probably something like that. And hey, Maker Mind Nexus, welcome on in. So these two, we're going to move over one slot because they're now going to go to power that Tobsun. The ends that we just cut and made shorter will strip and run into our inlets for the Wagos. And the stuff going into the Wagos, I've done a mixture. Some of them I had went ahead and put ferrules on, and we'll add ferrules to these now that I've made my final decision on cutting and placement. I tend to you don't need to use ferrules going into your Wagos. That, and if you're my voice is cutting out. It let me see. Yeah, I have been dropping some packets here and there, which has been affecting the quality of the stream. I'm also seeing a good deal of lag in the stream. It's been good lately, but I had a lot of lag built up earlier in the stream. So we're probably a good 30 to 40 seconds of lag. And those of you that have K40s, are you buying them secondhand off of like AliExpress, or are you buying them, or not Ali, are you buying them direct off of like AliExpress, or are you buying them secondhand off of like eBay? Okay. Wiring days always seem like a bit of a mess. Um, these I need some port connectors on. These I need ferrules. Yeah, it somewhat could be my internet. It could also be other people's internet, and it could be just Twitch and OBS because I've lost a lot of packets early in the stream, but I'm not seeing any more drop frames. Well, seeing a few drop frames here and there, but nothing major going on at the moment on my stream. So once again, now that I've decided my my final placement, or this is going to be the final placement, or I'm going to be redoing a lot of wiring. I'm going to go ahead and shorten these up, get ferrules on them. And hey, Turtle Crawler, how's it going, my friend? Yeah, it could be me. It is a little bit choppy. Like I said, I'm still seeing a few drop packets, but yeah, let's just say me and my ISP are not seeing eye to eye right now, and I'm about ready to have a conversation with them about if you're not going to provide me upload capacity, then we're going to have an issue here soon, and I'm going to start looking for. Unfortunately, my option is to switch to satellite, right? That's my option. And I really don't want to do that either because that's a whole different set of issues. Um, but if I go to satellite and I offload some stuff that might help, or the other side of that is possibly, um, not possibly, but I really need to get up in the attic and just run hardline up into the Dragon Den and run everything hardline that I can to get off the wireless in the house. Which I know we talked about that, and I just had my helper here all last week, and we never got off our butts and did anything. My helper being my oh god, quick math, 28-year-old son. God, that's hard to say. Oh, ah, what did I just do there? Completely missed the print. Awesome. Okay, Facebook Marketplace, I'm assuming. That's good. To the other side. All right, great. Yeah, I'm streaming at 1080p and what am I? 1080p 30 frames because when I was doing so I'd always been doing 4K at 60 and just letting it do its thing for however it needed to downscale on everybody else's end. But then I was having upload issues, and my wonder was whether or not I was being rate limited by my ISP on purpose or just because my connection sucks because I'm rural and I only have one game in town. So it's either Connect by Windstream or nothing. So, which sucks, but that's my option, right? Connect by Windstream or nothing. I've got no true cable providers, so I'm having to stream all of my TV and um, words are hard sometimes. Yeah, so I'm having to stream all my TV, and of course we've got like 30 plus things in the house running, and if I plug in all or if I turn on all the printers, then I've got upwards of 50 things on the network wireless wise. So most of all the printers are on as the 2.4 gigahertz range. So my thought is just to VHB this in place. You can cut and make this as short as possible. The 5 volt come over uh, into the screen and the Raspberry Pi, and then yeah, VHB this, and the SSR is going to be mounted over on this side. And my thought process here is to mark where appropriate, drill holes into this metal back panel, thread them, and then thread it right onto the back panel, and possibly put a little bit of like Arctic silver compound on here to help with heat transfer, and use this entire back panel as the SSR heatsink. Because once again, we'll have the load side plugged in, we'll have a ground wire that'll come in here and tap in, and then we'll have our low voltage input side. And I'll do it so that the load side is facing the bottom end, which will make all of my wiring to the bed as short as possible. So yes, that is my plan, is to mount this kind of low and about like right there, so I can bring the wires up, connect them in. Once again, bring a ground over, have my whatchamacallit, my bed inputs. And I'm going to try and come straight off the bed. If I can't, if it balks for whatever reason, then of course we'll come out of the HE1 like we've done on a lot of the um, LDO stuff, right? But that's my plan, is to actually mount this directly through this metal backing. Um, yeah. I am in North Carolina, and currently I cannot get Starlink in my area as a fixed location, but I can get the Starlink for mobile, like um what am I thinking of? People with RVs. Like that's what my brother is using at his RV that he keeps about an hour away down in Selma, North Carolina, is Starlink. But yeah, that's what I was thinking with Starlink. I just need to really think about how I want to pipe it into the house and how I need to push it. Powerline Ethernet adapter, that's an option too. Um, yeah, exactly, Nick. I mean, I've done it before. My preference, I was trying to see if I couldn't get this house wired at least in a couple of places, and they told me no, because they already had like, we got into it after the foundation was already laid. So it was like, okay, everything's been bought. We're waiting for everything to come in, because it was right as COVID hit. And so it was, we couldn't make any changes. And I wish I had argued and fought and tried to at least get them to let me run some network stuff in the walls. Um, but they didn't let me. So yeah. Okay, so we've got our 5 volt here. We'll go ahead and now I'm not going to um I'm going to be cheap, so to speak, and I'm not going to VHB this down just yet, because it's going to be easier to run the screws as I can hold it up like this. put the screws in. Then I'll put it in and run the wires, VHB it down, and plug the connectors in, because I don't want to have to sit here and try and work in small places, if I don't have to. So I'm going to hold off on installing this just yet, and when I go to power it back up, I'll power it with the external wall wart. And then when I don't want to mount the SSR just yet, because when I go to mount the SSR, of course, I'm going to need to drill, and I want to be able to, well, one, drill without, well, I guess I got the hand drill. I'm going to do that off stream just so I can make sure and do it right and not, because I am going to drill it and I don't want to make a mess and make a screw up. So I'm probably going to have to take this side panel off and lay it down so I can get in there with the drill and drill it straight up and down. And I'm going to have to do something with some tape on the bottom, just kind of create a trough underneath to catch any slivers so they don't get all in the motors and everything. So we'll work on that stuff probably off stream later tonight or first thing in the morning. Let's see, what else can we do? At this point, we still need to mount the bed. Then we'll have to do a little bit of wiring on the bed. So let me get this out of the way. That out of the way. Set this up. And I can't explain to you guys how heavy this printer has gotten just adding this back panel on. And all the weight that is this backpack, super crazy heavy. And one thing that you'll see when we go to do some of the other panels a little bit later on is the side panels will get mounted the same way. So you've got these thick aluminum spacers, and these will mount on each upper pillar. And then you'll have the shorter ones that'll go across. And so we're going to lay it on its side, lay these on here, then we'll lay the metal sides on top of it, and we'll screw through the metal slide, the spacer, and into the T-nuts. And so these add the spacing so that you don't have any rubbing on your panels on your motion system. That adds also to a little bit of the heft, because the aluminum, like I said, it adds weight. It adds weight. So now, let me spin this back around here. And we need to mount our bed. Now, I have made the decision at this point not to do the separate ceramic thermistor, because I really don't want to cut this open and try and, run the thermistor here, cut it open, add some splices in the wiring, because I have no way of doing it without it showing, unless I cut it here, bend this back, and do some type of Wago connector underneath the bed. So really the way this comes is it'll come in through the side, and it's going to rest, these three rods rest right in the bearings. Right, so just get it lined up, rest it in the bearings, make sure it's kind of, just give it a little jiggle. And then you'll have your springs that, once again, you screw into the three trucks, and that's what holds that bed down against those bearings. And that's what gives you your kinematic bed movement. And then your wire will feed through the back panel here and into there. So what I need to do is probably just kind of bring these wires together, put a zip tie on them, add a little bit of cable sleeving, which I have some of, and I'll cut everything to size eventually. But for now, I want to try and get the bed in here and get it plumbed up, except for, of course, the actual heating element, because I'll need to drill for that. And yeah, we'll get the thermistor plumbed and we'll be able to really start doing some checkout. And actually, as I'm talking, I don't want to put this in here just yet. We'll hold this out and I'll put in a thermistor, do my little dummy thermistors for now. Because once again, I'm going to have to put this on its side to try and I'm going to have to put it on its side to try and plumb everything. So I think for right now, this is where I want to stop and start doing some function check stuff. Make sure that we've got movement and that our motors are, we'll say, phased right and things like that. So what I'm going to do is turn it like this so you guys will be able to see the display. I'm also buying a 90-degree, what is this, ISC 320, what have you, the standard computer plug. I ordered a couple of 90 degrees because this is a little tight in here when you go to plug it in. Once again, I'm having a separate wall wart for the Raspberry Pi 5 at the moment. Excuse me, Raspberry Pi 4. So it's a 4B 2 gig. Going the other way. I'm going to turn the main PSU on, which lights up power to our controllers, and then the Raspberry Pi. And everything should be coming up. You should see stuff on the screen. Yep. And I know it's doing that. It's doing that because of some electrical interference on a couple of pins in the back. I know that's happening. It'll go away. Flipper's not going to come up because I still don't have a bed thermistor there. So I need to add in at least a bed thermistor. We have the tool head thermistor plumbed up, but I need to add a bed thermistor. So it shut down because ADC out of range. I just plugged in just a random thermistor in for the bed. So it's got a bed thermistor. So we'll do a clipper restart and see if we can get it to come up. Very nice tech cheaper. Yeah, that's what I want to do is look at like eBay or Craigslist, Facebook Marketplace, whatever, and see if I can't find one that's at a hell of a deal. And if I can, then great. Let me grab this. We'll bring this over here. This is our call it our smaller local camera, a benchtop one that we can move around. And as you can see, we've got clipper screen in here. So we've got a nice big clipper screen display. It is showing all of our temperatures now. So 23 for the extruder, 24 for the bed. SKR is at 32. Raspberry Pi is at 37. I don't have any of the fans plumbed in there yet. That's something else I need to do. And now I'm going to let me log into the printer interface. And we just want to see if we can get some things going, like can we heat up the hot end? So standard checks, and the standard checks that we do is always the let me go ahead and bring up the browser window, turn that on, change this to the browser. Okay, so you're kind of seeing both the clipper screen and the main screen. So what I normally do is go to the Voron design page and look up their documentation for initial printer startup. Right, so we come over here, we go to the documentation page, and we come down to the build and initial startup. Okay. But kind of what we're looking to do here is just do some basic checks. We've got temperature readings, and said temperature readings are pretty close to normal. Right, let me shut that off to remove some distraction. Okay, so our temperatures are pretty close between our hot end and our bed, so thermistors are set right and they're reading. Um, Now we want to verify our heaters. So it's just simply going into our heaters and saying, for the bed, it's going to be useless because we don't have a bed heater on. So for the extruder, I want to tell it to heat up to say like 80, right? Just to see if it looks like the target's going up, see if I feel any temperature happening. And there should be some type of part cooling going on. Now, I'm not providing an alternate voltage, so there shouldn't be anything going to the fans. They shouldn't be trying to move at all, any of them, and none of them are. And the hot end is getting hot. And it did overshoot, but we don't have a pig going, and we can't PID tune just yet. So I just want to make sure that some of the basic wiring that I did is working, and it appears like it's working. Um, Without having to take the tool head apart, like I said, I could probably plumb 24 volt into that one alternate power header and get all of the fans working. But should we do that, guys? Should we provide the alternate voltage up there? I mean, it's a quick fix to make sure that our cooling fans are working. The correct fix is to take the tool head off and resolder the boards, or those two pads on the board. Okay, Shada, you have the RV Starlink? Good. Now, do you stream over it or do you do everything over it? What you may see me doing is I just shut that down and I'm going to look through my pile of wires here and see if I've got anything that's already set up with a length of cable, which I'm not seeing, or at least not readily and easily seeing. It's got a JST connector on the end, but we'll make this one work. I only really need, yeah, this will work. I'm just going to make a quick pigtail and provide alternate voltage to that alt pin. I'm going to run 24 volt up to it, and that should let me check out the fans for the time being. Because once again, all the fans in the kit were 24 volt. We'll take a quick look at that. This is a Fabrico kit for the K3. So once again, 950 bucks. You do have to provide some things. Do they mention the fans in here? No, they just talk about the P series fan kit for the K3. Okay, so there were some things that we needed to source ourselves, which is what I did. Let me just double check. Yeah, that was the biggest one I was worried about was the 2510 for the actual hot end. But it looks like it's 24 volt as well. So what I'm going to do is I'm just going to create a quick pigtail for the alternate voltage. So let me shut those down. I'll plumb 24 volt directly up into that JST connector. I won't even power it from the board. I'm just going to bring it directly up from the Wagos. JST's on one side, and then strip some on the other. So Sheldell, where are you at in the States? Because I believe you are in the States, if I remember right. I'm just kind of curious if you got Starlink and where you're at. And thank you, Hybrid Robotics, for the resub for 5 months. Thank you, thank you. Hopefully, you continue to find my content worthy of your subscription and your time. Okay, so I got a positive and a negative. And what I need to do is take a quick look at the thing to figure out which order it goes. Positive at the top, negative at the bottom. Other side to go into the Legos. And everything is powered down. There's no um, lights on. Plug that in. And like I said, we're just going to bring this down and plug it directly into the Wagos for now to bring 24 volt up to the tool head. And down the road, if we want to, we can switch that over to the 5 volt really easy. Let's go ahead and hit power and hope for no magic smoke. No magic smoke. Should be good. Give me 1 second, folks. I'm going to step aside while this boots up and blow my nose. And I'm back. Sorry about that. So I just plumbed in 24 volt to the alternate voltage. So hopefully that means our fans are getting 24 volts now. So let's come over to our browser window. We'll look at our main sail, jump back on there. And if everything's working right, I should be able to scroll down here and turn our part cooling fan on by doing that. Or no, that's not going to be the part cooling fan. That would be the controller fan. So, no. This should be the part cooling fan, shouldn't it be? You know what, let's double check real fast. Now that we're actually in here, printer config, We'll come down to our fan section. Hey, MakerMind Nexus, I get it. This is a pretty cool build. This is an interesting build. I'm definitely so fan 0 is the print cooling fan. Fan 1 is the hot end. So I've got my hot end. I've got my fans reversed. So how do I want to do that? So fan 0 is part cooling fan. Fan 1 is hot end cooling fan. Let me double check that. Fan 0 is the green, and that green comes up into hot end fan. And part cooling fan is the blue and yellow, which is fan 1. So I've got those two swapped. So the easy way of changing that is, of course, just swapping the pins. So we'll make this PB6. Fan 1. This PB7. Fan 0. We'll do a save and restart. So if we turn this fan on, this should be part cooling. And our part cooling fans are on. So both part cooling fans are on now. So that's good. The part cooling fans work. Now let's take a look at our hot end again and just say 80. And our hot end fan should kick in as soon as it goes above 50 if everything is set right. Oh, you're in Newfoundland? Okay. Okay, and my hot end fan is not on. Okay. Hot end fan is not turning on. And that may be an issue. So let me show you. So the hot end fan is this connection right here, this white connection. So if you can see, my GST connectors and the wires are going to be extremely tightly pinched there because this mount piece has the fan on this side versus on the front side where it normally would be. And I think that may be an issue where this fan wire has been kinked from being jammed down on there. So we'll have to take a look at that. And I know, was it you, Turtle Crawler? Or is it Poity? Somebody, I think, redesigned this piece so that the fan comes around to the front. So we'll need to have a look at that and figure out if that's an issue. which is going to prevent me from PID tuning this, because if I don't have hot end fan, I can't PID tune this. I guarantee it'll overshoot. All right, nice, Shaudel. I'll definitely have to look into that. And I know I'm at the point where a lot of the equipment and stuff's going to be more expensive than it would normally have been, but so be it. So what else can we do? We don't have the bed, so we can't do the bed. We can't do the heater. Well, we verified that the tool head heater's working. What we haven't verified is that the um, tool head, we can't do a PID on the tool head because the fan's not working at the moment. Stepper motor, we can check that. Now remember, we've got an X and an X1, so each one of these will move independent of each other when we do a stepper buzz. But we want to make sure that our X motors are moving in the same direction. So where is my stepper buzz command? There it is. We're going to copy that. We're going to come back over to our Annex Engineering K3. We're going to paste that in. And when we hit enter, our X, which is the, this might be easier if we use the main camera. This X, which this is driving, yeah, the top. So this side should go positive, negative, positive, negative. So this I'm going to say is going the wrong direction because it's going back. So it's going left, then right. So that would be the wrong direction. Okay, and my hot end fan just went full bore. That tells me my hot end fan, okay, my hot end fan is now keyed to the wrong pin. So 1 second. Fan 0, fan 1, PB6, fan 2, which is PB5. Because my hot end fan is turned on and going, and your controller fan would kick in as soon as you do a motor movement, right? So that tells me that there is something wrong there with the pinouts. Printer config, sorry about that, death scrolling. So fan control. PB6 fan 1, that is our part cooling fan, and that is working as intended. The hot end cooling fan is plugged into PB7. And okay, so 0, I'm thinking 0 starting back here. 0 is apparently starting at the front and going back. Okay. As I say, not as I do. Do not plug and unplug things with the board powered on. Goodness. Yeah. So now our hot end fan is on and we're at 80 degrees on the tool head. So that's good. We'll shut that down. And it should drop it down to 50. And at 50, the tool head should shut off. So that was an issue of the fans are going 0, 1, 2 versus 0, 1, 2. I was reading it as 0 being towards the middle of the board versus the other direction. So our fans are good now. Yay. The stepper X direction, so the left stepper is in the wrong direction. Stepper 1. And once again, X positive is this way, negative is this way. It should go positive, then negative. And it is also going in the wrong direction. Okay. So we need to look at our Y's. And once again, Y positive would be towards the backpack and then towards the front. So we'll go to Y, which is this motor. So it'd be this side. Oops. Seriously. So this motor's going in the wrong direction. Chances are the Y1 is going in the wrong, will be going in the wrong direction as well. Yeah. So all of our motors are going in the wrong direction. Hey, Poondog, welcome on in. Okay, Hybrid Robotics. Hope you get to feeling better. Go lie down. Definitely go lie down. So all 4 of our X and Y motors are going in the wrong direction. So we need to go into our printer config. And it's going to be a simple thing of coming down to our X and Y motor settings. And in front of our dir pin, we need to add or remove an exclamation point. And that will reverse the direction. Now, notice that it goes in front of in this case, it's running on a secondary board. So it's AECS colon GPIO1 for the direction. So the exclamation point doesn't just go in front of the GPU, it goes in front of the whole board definition. So we'll do the same thing down here. So on the X1, we need to remove the exclamation point. On Y, we need to remove the exclamation point. In Y1 direction, we'll need to add an exclamation point. Now we'll do a save and restart. What did you do? Oh, I had questioned if it was you or Poity that had redesigned the fan mount for the Rapido 2 so that it faces the right side versus facing behind the 4010 fan. Because the way that mount is, it's got the holes for the two screws that go up into the Y carriage, Y linear rail carriage, and the only way it can mount is facing the back of the 4010 fan versus facing. So let me bring this. So right now, this fan faces the back side of this 4010, so it's sucking in air from around this fan, and it puts a really kink on that wire, which is the hot end fan wiring. If this fan was facing out like it should be, then it would not impact the wiring connector right there. But I can't remember if it was you or Poity that redesigned that for the Rapido 2 mount. But now that we've gone through and we've checked our steppers and we've updated our steppers, so this carriage should move forward then back. So the X motor is now moving in the right direction. Let's check the X1 motor. So same thing, but back here. And that's moving in the right direction. No, it's a good print. I had it in the wrong connector on the motherboard, so that's good. The fan's working now. It's just if this part was redesigned so that the fan came out in the front here, it wouldn't be an issue with those crimp pins at all. And I thought either you or Poity, one of you had said that you had redone that mount. Okay, and so now all of my X and Y gantries are moving in the correct direction. We need to check our Z motors now. So Z, we're going to look at the truck over here, and our truck should go, what, positive would be down, then up. So, and it's going up, which would be negative, then down. So Z0 is going the wrong direction. Z1, once again, we're going to want it to go down first, then up, because down is positive. And it's going up, then down. So that one's going wrong. Now we're going to do the same thing for Z2 here. Z2. So all of my motors were going in the wrong direction. So we need to go back into our config again. Go down to stepper Z and change the directions for all three of our Z steppers. So wherever our dir pin is, we will either remove or add the exclamation point for the direction. Do a save and restart. Okay, and we're going to start with stepper 2 again. So this one here. It should go down then up because that's positive and negative. So we're going to go over here and do Z, so this left side. Now we're going to come and do the back. This is Z1. And I'm getting a little hum out of this motor that I'm not getting in any of the others. So we'll have to look into that and see if it's just a power issue or what the deal is. It might just be that this belt is tighter than the other two. That might be an issue, is different tension. But we just checked and all of our motors are now working in the right direction. So that's good. In stop check. Now we're using X and Y is a what you call it? X and Y are sensorless homing. So we should be set up for sensorless homing. What I'm going to do is I'm going to home X and see if we're going to home in the right direction. And then, because it's going to home to the positive side, and then Y would be, we're homing to positive on X, negative on Y. Doesn't make sense. But that's the way all the end stops are set. So I'm going to double check how we're set up in our config. So we should be homing towards the this motor. So X positive, Y negative. So X min max, the position of end stop is 180. Y, okay, and Y is set to min as well. Okay, so that's good. So it should be coming towards this motor. So what I want to do is I want to home X, and it should be homing towards the right, and it should hit, and we're doing sensorless. So if everything is set right, it should hit and bump without a bunch of grinding. So we're going to home X individually. So I hit the emergency stop. It was doing a bit of grinding, so that sensitivity is inappropriate. So we're going to have to update the sensitivity. I'm going to check the Y and it should come forward. And once again, it should, it'll hit and we'll see if it grinds or not. So both X and Y were hitting and grinding, which means the sensitivity is not sensitive enough. Yeah, not sensitive enough. So now is where we get to start tweaking and playing. And once again, it depends on your sensorless homing depends on a couple of things. Voltage, speed will also change how hard it hits and how much feedback it gets, right? So a couple of things I want to do is one, just verify 100% that I've got sensorless homing set up correctly on the Constellation board. Because if I don't, I'm going to run into issues. So let me come in here, take a look at the Constellation board, and we got an ad break in progress. Yeah, I could see how that would work too. So going out the beacon side, you would have to what? Mount it to the Y carriage first, then install the fan? Because otherwise the fan would get in the way of the screws. But yeah, I could see that going as well. Um, so what I'm doing is I'm looking at my printer config, and yeah, I'm using run current is 1. Sense resistor. I'm looking at rails, sensorless homing, 5160. I think this is the one I used, which EMC driver 5160s, run current of 1, sense resistor 0.075, your driver SGT, which is your sensitivity for the sensorless homing, is set at 2, and we're hitting and we're not sensitive enough, which means we need to go to a lower value. And in this case, the value ranges between -64 and +63. And because X and X1 and Y1 are moving towards the same spot, we really need to make those the same value. So the X's and the X's need to be the same, the Y's and the Y's need to be the same. So just be cognizant of that. The other thing I wanted to do, this is the clipper config. What I really want to do is, without looking at the firmware, I want to look at the PCBs and just make sure once again that my Constellation board is properly configured. Constellation Supernova. So sensorless homing. Um, to enable sensorless homing, switch the dip switch labeled homing to on. I'm going to double check that all of my, since I'm doing sensorless homing, I want them all in the on position for homing. And they all are in the on position. So I should be set up for sensorless homing on all of them. And they're all configured for diag 1. So that's good. So the issue is truly not a configuration issue from a mechanical perspective. It is a sensitivity setting issue. So what I will do is I'm going to just switch these. Since we need it to be more sensitive, I'm going to switch these to a -2 all the way through. And we'll keep trying and we'll just keep moving it by a couple at a time until we find the right sensitivity. And of course, I can't even work on the beacon until I actually mount the bed. So once we get the bed mounted, we'll work on the beacon. Don't know how much longer we'll go tonight, but we'll see. So we've done that and we've rebooted. We did do a firmware restart, right? Already still home X. And I'll say stuck because I think that sensitivity was too high now for both of them. So now the sensitivity is set too high. So let's go back to 0 for both of them. For both axes. So all 4 motors, we'll set them to 0. So it's a little bit different when you're doing centralist homing on something doing UART, which is like your TMC 2209s. Your sensitivity range is 0 to 255. When you're doing SPI, it's -64 to +63. So we should be right in the middle. So this is basically, let's say, like 50, right? So let's see if we get any movement. X is all the way to the positive, so let's move that back 100. Y is at the negative, so let's move that back 100. So we've got good movement. Our Z-axes are all the way down at the bottom. So we can't necessarily home it because, or it's at the max position. We can't home it because we won't have anything to trigger beacon unless I like physically hold a metal object up there, which I guess we can try and do. And it says no beacon model loaded. Okay. No beacon model loaded, and it dumped. So, beacon. So we have a basic beacon configuration. -20 offset, correct. Y offset 0, that's correct. We can't have mesh main and mesh runs uncommented until we have a first bed mesh. We should have been doing safe Z home, which would have moved X and Y into the middle and ran that. Any idea, Turtle, why we took that error? So the error we got was no beacon model loaded. So we did the beacon installation. We've done the clipper module. It's being seen. We did the Moonraker upgrade. We've got our beacon information there. So those two, this piece. Pretty sure our Z stepper stuff is set correctly. Oh, virtual in-stop. Homing distance is 0. As small as 1. Thank you for the follow. I appreciate that. Home the machine in X and Y. Probably because we haven't done any calibration yet, huh? Yeah, we haven't done any calibration yet, and we can't do that until I mount the bed. So I can physically mount the bed, not connect anything up as far as the bed heater and stuff goes at this point, and we can get movement of the bed plate and things like that. And then I can take it back off. See, that's the thing is I didn't want to put it on there because I'm going to need to drill some holes in the back to mount the SSR as appropriate. And I didn't want to have this in the way, though. If I put it all the way down, it should be fine. So, how are you doing today, Smalls? Hope all's going well. You had a good New Year's, good Christmas, holidays. And Turtle, if you've got a new file, I wouldn't, I'd reprint it, and much as it pains me, tear my tool head apart and redo it. I have to take the tool head partially apart anyhow to resolder those joints on the carabiner. But yeah, if you've got the files for that, I wouldn't mind getting them. Hey, KB3D Chris, how's it going, my friend? How is it going? We're getting a bed put in place just so that we can possibly test out our beacon and get our beacon going. We've got our X and Y motors moving. We've got our sensorless homing adjusted as appropriate. And now I'm sitting here installing the bed. And if you want to see a grown man cringe, I just realized the screw that comes in here comes in from behind, which means it'd be a lot easier if I didn't have this metal piece here. So that ought to make it fun. And get this screwed in. Because that means I'm going to have to use an Allen key to do this whole thing. Um, We also need to find a 2.5 millimeter Allen key. Anybody got one of those handy? Better yet, anybody know where I may have put mine a long time ago in a galaxy far, far away? Okay, folks, I may need to put you on a be right back screen real fast while I go run downstairs. I think I've got one downstairs with the Ender 5 Plus. So yes, Happy New Year, Chris. Happy New Year's, Ram. If you guys and gals give me just a couple of minutes, I'm going to put you on mute so I can run downstairs, and I will be right back. The drop game is active, so if you guys want to drop, or if either one of my mods want to do some raffles or anything, feel free. And like I said, I will be back momentarily. Thank you. Okay, one downstairs where I was expecting, so hopefully this is a 2.5 millimeter. And hey, Chewy, welcome on in. Welcome on in. Yes, this should be good. Hey, West3, how's it going, sis? Hope you're doing well. Hope things are getting a little bit better. So we've got all of our motors installed. We've got our directions set for our X, Y, and Z. I've got so currently at the moment, I'm piping 24-volt up into the carabiner through both um, the hot end as well as the alternate voltage path, because I didn't realize at first, but the carabiner board, the pads are soldered to connect it to the alternate voltage and not the main heater voltage, which means that they would be set up to, normally you'd pipe 5-volt in for your probe or whatever. So um, the more elegant way to do it would be to take the extruder off so I can get to the pads I need to, and desolder the voltage to alt and solder the pads between voltage and main for both fans so that they will be working as appropriate. So that may happen off stream. Right now we're putting the bed on because we've got X and Y homing, and we need to test out the beacon. And the beacon just kind of threw an error, and the only thing I can think of right off the top of my head is that we haven't done any calibration on the beacon yet. So that may be why it threw an error when I tried to home. So let's see if we can get some type of basic calibration for the beacon. To get my build plate. And as you may be able to tell, my heated bed's not plugged into anything right yet. I'm using a thermistor, just a standard glass bead thermistor on the back to act as a thermistor. Sorry about that. So we're going to follow the calibrate beacon to see if we can get past our error that we got, which was no beacon model loaded. I'm unsure what that is. So let's do a firmware restart again. Let's do some copy paste. So we'll do a G28 of X and Y. And that initial noise was it tries to lower the bed for safety reasons before doing an X or Y movement, and it's already down at the bottom. So that's where it was just like skipping basically. So we've homed X and we've homed Y. Now position the nozzle in the center of the bed. We're just going to go with this. It's just going to be close enough to the center. It's a 180 by 180. little bit closer. Okay. Then it says to do a beacon calibrate. I'm going to assume that this is going to be the standard um, calibration type stuff. Ooh, that's going to go slow. Let me see if I can, was it G1Z80? Yeah, it won't let me do it because it's not home yet. Oh my gosh. And of course, we're going to need a Post-it note or some other form of paper that we can use to set our offset. That just went tight, so we'll push that back down and we'll drop down one. That went tight, so we'll open it back, or we'll raise it up 0.1, drop down 0.05. I like that right there. We'll accept that. Now it's going to, you have some Allen keys you cut down just for places like, yeah, makes sense. Flex driver for, yeah, that works too. So the beacon calibrated 127.2590 from okay. So we've calibrated beacon. So let's do a save config. There is a bit of a gap, so I can get the paper underneath there. So that's good. So okay, so we've done this. It says for the first run, it's perfectly fine to calibrate cold. For longer term use and to get the best temperature performance, it's best to bring your bed up to temp and do all that, but we don't have the bed done yet. So it says we can use a beacon query to query the beacon for where it's at. The last reading, the hertz at a temperature range and a 0.20595 millimeters. Okay. So, yeah, I guess it's that time. Home all. Bed drops. We go over and we check left and right. Okay. Tool head stopped below model range. So what I want to do now, because we're a lot closer, I'm going to do a beacon calibrate again. Most home XY. Okay, well, let's. Home X, home Y. Then we're going to do a G0, G1. We're going to basically go through and redo that calibration again. Since it's a lot closer now. It was still not at 169, but nice try. Good, Westry. I'm glad things are going well. Yeah, I hope things are really going well for you and your mom's doing better. Um, I know that that's kind of rough. The one thing I want to do here is just check on my Z. So my position min is -5. For giggles, I'm going to make that -10 for right now. So that allows me to go further into the negative if need be. I think that could be part of the problem. So we're going to do a home all basically. Okay, so we did a home all. So that was probably part of it, is we couldn't go negative far enough. So we've got home to Z. Now what we want to do is a probe accuracy. So this is going to basically test the repeatability of the readings. So in this case, you're going to see me, I'm going to step back and I'm going to try not to move around because I don't want to cause this thing to shake. So I don't want to lean up against the table and stuff like that. That was pretty quick. Our uh, deviation was 0.000788. So not bad. Not bad. We want to estimate the backlash of our z-axis. So we'll run that now. The backlash or delta between moving up and moving down is 0.00942. That helps it understand its sampling rate some. And now let's just do a bed. Actually, before we do a bed mesh, let's do we're going to rehome. We're going to do a Z-tilt to make sure that our Z-tilt is set, or our bed is, all three corners of our bed are level. Oh, yeah, so Westery, since I've got you and Steve in here, while that is going and doing its thing, let's just go for the size comparison. Shuttle, Annex Engineering K3. So tails touching. This thing is beautifully printed, Stephen. I'm not even sure how many parts that are on this, but this thing is beautiful. We've got the Westery Research, because that's how it was printed. Your solar panels do fold out. It does come out, and the solar panels will fold out. The arm does telescope, but you don't want to use this to try and hold the satellite up. The satellite's just too much weight for it. But yeah, this thing is chonky. Awesome print, Stephen Poole. And thank you again, Westery, for sending this out to me. This is amazing. Okay, so we did our Z-tilt adjust and our tolerance got down to 0.007. And now let's go ahead and do our first bed mesh. I think it requires us to home, so we'll home real fast. And just like that, we just meshed the bed. And we look at our height map, and there's a deviation of 0.140 millimeters across the bed. Yeah, let me move some things around here real fast. Get that out of the way. I'm gonna scoot some things around. Just did a save config. So let me put this over here. Once again, bed's not attached, so we'll just keep that out of the way. So it just did a firmware reset to save that bed mesh. But we're going to home all. Once again, X and Y homing is sensorless. So we've homed. We'll do a Z-tilt adjust. Hey, Ipaku, how's it going? Doing good, doing good. Now, Ipaku, I got to ask. You say, how you doing, boss? Are you actually one of my coworkers, or you just giving me props and making my head even bigger than it is? So we just did our Z-tilt. I'm going to go back ahead and home again. Get us back in the center. And then once again, we want to do our interesting. Yeah. I don't know why it did its little crap out there. Okay. Now we're going to do our bed mesh calibrate, and I will bring you guys down here, or at least a little bit over here, so you can see a little bit more of how this bed mesh calibrate happens. Ready? And it just meshed the entire bed, just like that. So I will say that will be quicker than even tap probing, because you can make it go so much faster while you're doing your bed mesh. And once again, our height map, and it was repeatable where our range between across the whole bed is 0.140 millimeters. That's exactly the same thing that we just got before. So at this point, we've got our motors validated that they're going in the right directions. I'm going to remove my little tabs of X. Well, this is X. This was X, Y, Y1, X1. we'll work on shortening up all the motors and stuff. Hey, Jerry 3DP, welcome on in. Welcome on in, my friend. I still need to get the bed wires cleaned up, routed through here. We've got some cleanup to do on the back. In fact, let me go ahead and actually, you know what? While we're chatting, let's go ahead and PID tune the hot end. Wise doing, our homing is going in the right direction. Bed leveling is done. Our Z-tilt's done. Our beacon probe is working. PID tune. Can't do the heated bed because the heated bed's not plugged in just yet. But let's PID tune that hot end. So the hot end in this case, sorry about that. The hot end in this case is a Rapido 2. It is configured in a ultra high flow configuration with a 0.4 nozzle. Let's see. We've got our beacon probe installed and got all that. So this is an interesting tool head. So this is looking at it from the front of the printer, right? So X is this direction, Y is front to back. So it's interesting to see the part cooling fans on either side, on the front to back versus the side to side. When you look at it from this vantage point, this is our Rapido 2 installed, our part cooling fans. This is the 2510 fan right here for the hot end. And then on the left side, this is our beacon probe. Yeah. So that's the beacon probe that we've been using for our probing. And that's a pretty darn rigid hot end. A little busy, but it is rigid, right? We're using a Sherpa Mini for the extruder. So it's direct drive. And you'll notice there's a mounting boss right here to the left. That's going to let me mount a end stop, a standard end stop without the lever on it. I'll add another screw through the top hole here on this lever that will line up with the end stop plunger. And I'll be able to use this as a filament runout detection sensor. And that'll come in handy because the plan is to mount a trad rack on this. And I've got a 12-lane trad rack ready to go on this printer. So, yeah. And while it's going through and doing its PID, I'll bring you guys around to the back here. And once again, a little bit busy. Let me switch scenes here. Whoops, that's not what I wanted. There we go. So at the very bottom, we have a UHP 248, so that's 48 volts. A UHP 224, so 24 volts. This is on my main